In this section, we're going to be talking about errors that can occur during the hypothesis testing process and also using Excel to perform full hypothesis tests. So when you perform a hypothesis test, there are basically 4 different outcomes that depend on the actual truth or falseness of your null hypothesis and the reached decision about whether to reject it or not. So everything kind of sort of matches up and you get these 4 possible outcomes because either your null hypothesis is really true or it's really false. And then you either decide to reject or not reject. And when you kind of pair up all those combinations, you get 4 outcomes. 2 of these 4 outcomes are correct outcomes, but the other 2 combinations result in errors. And since humans are involved in this testing process, errors will definitely happen. So we need to understand them, we need to know what they mean, and we need to know how to minimize them. Okay, so here are all of the possible outcomes, the ways that all of these decisions can be paired up: 2 correct, 2 incorrect. So one possible outcome that's correct is that we decide to reject the null when the null is actually false. So it's a great thing to do, right? The null was false and we decided to reject it. That's a correct outcome. Another correct outcome would be deciding not to reject it when it's true, because we wouldn't want to reject it if it's true. That's a correct outcome as well. But now the other 2 combinations result in errors. So the first incorrect conclusion that we can come to is deciding to reject the null when it's true. Okay, so you see how that would be a bad thing to do if we reject it, but it's true. So this is actually the definition of that significance level alpha. We've already talked about that alpha is the probability of this error, the probability of rejecting the null when the null is actually true. This is defined or called a type 1 error. There's another error that can happen. This is when you decide not to reject it when it's false. This error is represented by the Greek letter beta. Beta is the probability, again, of making this specific type of error, and this is called a type 2 error. And then we have an image here, just this little table that sort of lays it all out in a visual way if you're more of a visual person, but it's the same information that I just said. It just kind of lays it out in more of a table, where the null hypothesis is either true or false. If it's true and we reject it, that would be bad. That is a type 1 error. That is our alpha. If it's true and we don't reject it, that's a good outcome. That's a correct outcome. If the null is false and we reject it, that's also correct. But if the null is false and we do not reject it, that's that type 2 error with a probability of beta. So let's look at a scenario. In this scenario, we want to identify both the type 1 and 2 errors and see which one seems to have the greater consequence in this specific situation. Okay, so our null hypothesis for this example is that Frank's rock climbing equipment is safe. We assume that it is safe. He just bought it from a company, he got it out of the package, he's putting it all together. You would assume that this equipment that he just bought is safe. But our alternative hypothesis here is that his rock climbing equipment is not safe. Let's look at what the 2 different errors would be defined as. So a type 1 error, if we go back up and look, is rejecting the null when it's actually true. So a type 1 error would be rejecting this null and thus concluding that Frank's equipment is not safe. So we would rejected the null. So we concluded that it was not safe when it really is safe. So deciding to reject the null when the null was actually true. So his equipment really was safe, but we rejected that idea and concluded that it wasn't. Okay, so then the type 2 error is the reverse of that. That is when we decide not to reject the null when the null is actually false. So this would be like concluding that the equipment is safe, right? Because we are not rejecting the null, so we are keeping this. So this is like saying, nope, we don't reject it. We're saying we're going to keep this. So deciding or concluding that the equipment is safe when it really is not safe. So which one of these will have the greater consequence? In this particular case, it would be much of a bigger consequence, a much bigger problem to make this type 2 error. This would be a way worse error to make. Right? Concluding that it's safe. If you conclude it's safe, then Frank's going to hook it all up and he's going to go rock climbing, but his equipment really isn't safe. Frank could be in big trouble in this case if we make this type of error. The type 1 error, it's still not great if we conclude that it's not safe, but it really is. Well, then we've concluded it's not safe, so perhaps Frank returns it and has to wait for a new set of equipment to come in, or perhaps he throws it away and has to spend more money buying a new one. So it's still not a great scenario, but his life is not in danger in that case. Okay, so usually one of the situations is, quote, worse of a scenario than the other, and that is going to totally depend on the context that you're looking at. For statisticians, typically the type 1 error is usually considered worse. Okay, that's the one we're used to. That's that alpha value. That's the one we've already talked about. That's usually the one that statisticians are trying to avoid. But in practice, like we just saw, either type of error could be worse depending on the context. And there is also this trade-off between the two error types. So if you set a lower significance level alpha, that will decrease the likelihood of that type 1 error occurring, right? We've made the probability of that alpha error, that type 1 error occurring. But when you do that, the flip side is that it actually increases the likelihood of a type 2 error occurring. Same thing with beta. If you set a lower beta value, that will decrease the likelihood of the type 2 error, but in return will increase the likelihood of a type 1 error. So if you've been thinking as we've moved along, as we've talked about these alpha values, like why wouldn't we just set alpha to 0? We don't want any probability of an error. Well, here is why we can't do that. If we set that to 0, then the likelihood of a type 2 error would be outrageous. So there's this give and take that, again, the person in charge has to kind of decide on their own. They have to weigh all of the possible consequences and then set these values using their best judgment. And of course, these values will be included in the write-ups about these hypothesis tests. When these tests are published, they will have to publish that information as well so that the reader, whoever's reading that, can also use their best judgment in their interpretation and whether they think maybe there's too high of a probability that what has even been published could have an error in it or not.